All right, today we're going to dive into something called 5G network slicing. And look, this isn't just another small upgrade. We're talking about a complete, radical rethinking of how mobile networks actually work. It's like creating a custom virtual highway for literally everything we do online.
But just think about this for a second. How can one single network possibly handle a self-driving car that needs a perfect, instantaneous connection to avoid a crash, while at the same time you're streaming a 4K movie that's gobbling up bandwidth, and a smart factory nearby has thousands of sensors just sending these tiny little trickles of data? How does it all work at once? Well, to really get the solution, we first have to understand the old problem. The way we used to build networks, it's just not cut out for this new, incredibly demanding world. So, if you think about the older networks, 2G, 3G, even 4G, they were all basically one size fits all. Imagine them as a single lane road, right? And you've got a super fast sports car, a delivery drone, and a slow moving tractor all stuck in the same lane. It's just a recipe for a massive traffic jam. But 5G, it's designed from the ground up to give every single one of them their own custom. And that's exactly where 5G's superpower comes into play. It's a little something called network slicing, and it is the tailored solution that finally addresses all this complexity. Okay, so the official term is network slicing. Yeah, it sounds pretty complex, I know, but the core idea is actually super simple. You're just taking one physical network and digitally carving it up into multiple, separate virtual networks. And the key here is that each one is completely independent. This right here is the best way to think about it. It's a highway, but we're not building more physical roads. Nope, we're using software to paint new, dedicated lanes onto the highway we already have. We can create a super wide high-speed lane for data-hungry video, a tough heavy-duty lane for industrial machines, and a totally clear, dedicated emergency lane for those critical services. Now, this idea doesn't just pop out of nowhere. It's actually been evolving for decades. The whole concept of a network slice first showed up way back in the 80s. But the real game changer, that came with something called software-defined networking, which basically lets us control how a network behaves with software instead of clunky hardware. And that's what finally made these virtual slices flexible and powerful enough for 5G. So how do we actually build this virtual highway? Let's break down the architecture. I promise it's simpler than it looks. It all boils down to three basic layers. First, you've got the infrastructure layer. That's the physical stuff, right? The pavement, the cell towers, the fiber cables. Then you have the network function layer. This is like the traffic rules and the road signs, using virtual software to direct all the traffic. And finally, there's the service layer. That's what we actually see, the cars, the trucks, the ambulances using that highway. And here's a look at how those three layers all fit together. You see the physical infrastructure down at the bottom, those network functions right in the middle, and the services we use up at the top. But the real magic is happening in that little box over on the side. So that box, that's the brains of the whole operation. It's the network slice controller. You can think of it as the central traffic control for this entire virtual highway we're building. It's the orchestrator that's watching everything, deciding who gets what resources, and making absolutely sure that each lane, each slice, is running perfectly, exactly according to the rules we've given it. Okay, that's enough theory. Let's talk about what this actually means for us. How do these dedicated lanes really change the game in the real world? Well, there are three main types of slices we're talking about. The enhanced mobile broadband slice. That's your multi-lane expressway guaranteeing insane speeds for stuff like 4K streaming or VR. Then you've got the ultra-reliable low-latency slice. This is the emergency lane, zero delays, perfect for critical tasks. And finally, the massive machine-type comm slice. This one's for the slow, steady traffic of millions and millions of tiny smart devices. Let's really zero in on that emergency lane. For an autonomous car, even a split-second delay in communication could be the difference between a safe stop and a terrible accident. This slice guarantees that the signal gets through instantly, every single time. It's a lifesaver, literally. And what about for the rest of us? Well, imagine having a guaranteed fast lane on the internet, a slice that's dedicated just to high bandwidth means your big game download or that live sports stream will never buffer again. Why? Because it has its own protected lane, completely immune to any other traffic jams on the network. Now, this technology is incredibly powerful, but we're not quite at the finish line yet. there are still some pretty important challenges to solve as we pave this road ahead. Yeah, building this superhighway isn't without its hurdles. You've got three big ones: security, quality, and, well, money. First, security. Each lane has to be perfectly sealed off so a virus or an attack in one lane can't cause a massive pileup in the others. Second, you have to guarantee the quality of service. That means making sure each slice reliably delivers on its promise, whether that's lightning speed or zero lag. And finally, you got to figure out how to sell it. Operators need business models to actually offer these custom highway lanes to the industries that need the most. And this brings us to what is, for me, the most exciting part. Network slicing fundamentally changes the conversation. It's no longer about what can the network do, it's now what do we need the network to do. It creates this flexible, programmable foundation for all kinds of innovation we haven't even thought of yet. So the real question it leaves us with is this: when our network can become anything we need it to be, what are we going to build next?